Hello again. Let's have a little look at Prim's algorithm. This diagram, A, B, C, D, E, F, G, H, I, J, K, they all represent towns, and all the numbers represent the distance between those towns. So 10 kilometers, 9 kilometers, and so on. We have to find what is called the minimum spanning tree, or the connecting things between all those towns, so that all the towns are connected with the minimum amount of roads. We will not be using every road, of course, because if you use them all, that wouldn't give you the minimum. They all need to be connected with the minimum number of roads. The algorithm goes like this. You can start anywhere you like. They all have to be connected, so it doesn't really matter which one you start at. So I will start right in the middle at G. So here we go. That's where I'm beginning. Then you look for the smallest number that is from your point that you've got. And I've only got G, so the smallest number there, I've got 7, 8, 9 or 10. 7 is clearly the smallest. My first route will be down to J. There we go. I've gone 7 to get to there. I have now got G and J, and I look for the smallest number that's nearest to them. So from J I've got 11, 9 and 12. From G I've got still a 10, a 9 and an 8. 8 is the smallest. I'm going down the 8 because it's the smallest one. Now I can look at G, J and H and find the smallest number. Now I've got 10, 11, I've got a 9 here. I think, oh, there's a 9 here from G to F. There's also a 9 here from J to B. When you have two that are the same, 9 each time, it doesn't matter which one you do. You'll get, so you can choose whichever you like. I think I'm going to go along this one over here. I'm going to go to up there. Okay, then again we do the same thing again. We now look for the shortest. From B I've got a 10 and an 8. I think 8's going to be shorter than everything else. I've got 10, 9, 11, 10. Yep, I'm going along the 8 up to C. And then the shortest from there again will be the 7. That'll take me across to D. And then the shortest again, that's from looking at all the points I've got, will be the 4, which will take me down to there, and the smallest again, well, 2 is bound to be the shortest there. Take me to that. Now, where else do I go? The shortest numbers I haven't been to I, and I haven't been to A. Now, notice here, to get to I need to go 10 or 12. To get to A, I need to go 10 or 11. There is a number 6 in the middle here. Let me use just a different colour to highlight it. Let's use that one. We've got a 6 here. It is the smallest number of all the ones I've got to that I haven't used, but I won't be using it because I've already connected up D and F. You don't bother connecting that up with something that you've already joined. So even though it's the smallest number, I'm not going to use it. Right. Let's go back to the ones where I only have to get to I and A, because then everything will be joined. So I just need the shortest number to get to there. There's a 10 there and there's a 10 there. It's not going to make any difference which one of those 10s I use, because it's the same number. So I'll use that 10 to get to there, and then I'll use that 10 to get to there, and that will give me the minimum spanning tree. You can work out the length of it by adding up all the numbers that we've got. So we've got 8 and 7 and 10. So I've got 10, 8 and 7. That's 10, 8 and 7. And I've gone here and I've got a 9 and a 10. Up here I've got an 8 and a 7. Then I've got a 4 and a 2. And that's it. I just check I've got the right number. That's 1, 2, 3, 4, 5, 6, 7, 8. Should be 9 numbers. 1, 2, 3, 4. Yep, 9 numbers. 6, 13, 21, 30, 45, 5, 4 and 2 make 65 kilometers is my minimum spanning tree for this situation. So that's Prim's algorithm. You just look for the smallest wherever you are, and just keep doing it until you get to the end and you've joined up every point. Okay, that is that.